name is Daniel, and in today's video we are going to do our first example under superposition theorem. Previously, I did the intro to superposition theorem. If you haven't seen this, please locate this video on the Twitter channel on YouTube. You can also locate a portion of this video on Twitter_think on our TikTok channel. So let's box on to what we have today. In this one, we have a very simple circuit and we are told to use superposition theorem to solve this. So like I explained in the previous video or in the intro video, let us see what we can do here. You need to look at the introduction. It will help you to follow me as I solve this one. So the first thing we are going to do is that anytime you come across something like that, what are you supposed to do? The first thing you need to do is to draw your diagram and label the branch current. Okay, we draw the original diagram, we label our branch current. So we have 7 volts here, we have another source which is 28 volts, then we have our 4 ohms, 1 ohm, and we have what, 2 ohms here. So now let's assume that this 28 volts is supplying a current on this branch, so it will move in this direction. So let's label this current as our I1. Okay, let's assume that the 7 volts is also moving in this direction. You can move in this direction, okay? You can decide to move in this direction. But let's assume that we are moving in this direction. Let's label this one what? I2. Now when I2 and I1 meet at this junction, they will move in this direction. Okay, so once they move, we will call this side what? I3. Now, in the introduction, we realize that the next thing we need to do is to close one of the source. We maintain the first source, close the second source, or you can maintain the second source, close the first source. Alright, so we close this source and we introduce the internal resistance, or we short circuit this side and we work with only the 28 volts. So let us draw the diagram here and close what? The 7 volts. So now watch very carefully. You need to label the branch current for the 28 volts when it is active. That is why I wrote when 28 volts is active. Okay, so now we will supply the current on all the branches. Now 28 volts is supplying the current in this direction, so let us call it I1 prime. The reason is that on the original diagram, I labeled that current what? I1. So I need to separate it with what? Prime. So I don't get confused. Now I1 prime will move in this direction. Once it gets to this node, it will split into 2. One is dropping in this direction, the other is going in that direction. So the one in this direction, let us call it what? I2 prime. Then the one dropping in this direction, let us call it what? I3 prime. Now do you get it? My diagram is too small, but then I hope you can see. Now what is the next thing that you need to do? The next thing is to find the total resistance for this circuit so that we can find the value of the supply current. Note that the supply current is I1 prime on this diagram. So we will find RT, okay? So our total resistance, let's do that calculation here. From this diagram, our total resistance RT will be equal to, now watch, this and this are parallel to each other. So this times this divided by this plus this. Then that solution will be in series with the 4. Watch the intro video, it will help you to understand. So I'm just going straight for it. So I have my 1 times 2 divided by 1 plus 2 plus, it will be in series with this one, so we have plus 4. Note that once you resolve this and this, you have a single resistive value which will be in series with what? This. If I redraw the diagram, it will behave like this. Okay? Now this is how the diagram will be. So we will have our 4 ohms here and we will have our resolved value which is what? P1. So this time this over this plus this is RP1, which will be in series with the 4. When I join it together, I'm having this. That is why I don't need to draw this diagram to continue this. So I just add the 4 to the solution to complete the total resistance. So when we punch this, we are having our what? RT giving us what? 4.6667 ohms. I want you to be leaving your answer in 4 decimal place. It will help us to finalize the final answer, okay? Because if we don't put it in 4 decimal place, it will be affecting the values we'll be getting. Now, after you've been able to find the total resistive value, the next thing we need to do is to find the supply current. So I can find my I1 prime as I1 prime equal to the total voltage divided by what? The total resistive value. So we have V divided by RT. This is giving us 28 divided by what? 4.666 what? 7. So now when you divide this, the result is giving you what? 6 amps. Remember that when you punch this, you are getting 5.999 something. You run into the nearest whole number, giving you 6 amps. Now, I have been able to find the supply current, which is I1 prime. It is important that I use that to find the remaining what? Current. So to calculate for I2 prime and I3 prime, I can use the current divider rule. If you haven't seen current divider rule, you can also locate current divider rule and its examples on the Twitter channel in the same playlist. So now when you look at this one, I can find this one by using this resistor and this one. So I can find I2 prime will give me now current divider rule says that take the supply current, which is I1 prime, the value is 6 amps. So I'll write myself, but let me quote the formula. It says that take the supply current I1 prime, use it to multiply the opposite one. Now, I2 prime is passing through this resistive value, 1 ohm. You don't need to take the 1 ohm, take its opposite value, which is this, which is what? 2. So I'll multiply by what? R2. This side is what? Called R2. Then we divide the result by this R2 plus this R3. This is called R3, okay? So R2 plus R3. Now, when you put in the values, we are getting 6 times 2, 2 plus 1. So now when we divide this is giving us 12 over 3, giving us what? 4 amps. So now that I've been able to find I2 prime, I can find I3 what? Prime. I don't need to use current divider rule. You can use it. If you want to use it, take the supply current, this one, use it to multiply the opposite resistor, which is what? 1. Divide by 1 plus what? 2. Like this, you get the correct answer. So now I'll use Kirchhoff current law. My I3 prime is giving me my I1 prime, the supply current. So when I subtract I2 prime from this result, I'll get the answer. So therefore, I3 prime is giving us what? This value is what? 6 amps minus 4 amps, which is giving us what? 2 amps. The next thing we need to do is that we are coming to consider when 7 volts is active. So let us redraw the diagram when 7 volts is active. So from the diagram, let us label the branch current. Let's assume that 7 volts here is supplying the current in this direction, okay? So let me call this one I2 prime prime. So now, as I2 prime prime get to this node, it will split into two. One is passing in this direction. Let us call that one I1 prime prime, okay? Which is similar to the original. Then when we drop here, the one that is passing here, we call it I3 prime prime. Now, we can find the total resistance of this circuit and find the supply current because we already have the voltage source. So once we find the supply current, now note 7 volts is supplying I2 prime prime, so that is the supply current. So we have to find it first. To do that, we need the total resistive value of this circuit. Now, another trick you should know is that because the 7 volts is here, let us resolve from this side, okay, from the left to the right. So to do that, we have 4 here, which is parallel to this one, and then it will be in series with what? R3. So I can say that my RT is giving me 4 times 2 dividing 4 plus 2 plus this one, which is here. Do we get it? So therefore, our RT is giving us 2.3333. Leave your answer in 4 decimal places. This is in ohms. Alright, so now that we've been able to find RT, we can find the supply current I2 prime prime. And to do that, I'll write my I2 prime prime, giving me the total voltage V over RT, giving us 7 dividing 2.3333. Now when you divide this, you are having 3 amps. Okay, now we can find I1 prime prime, I3 prime prime. Using area divider rule, I will just write my I1 prime prime, giving me, now use the supply current, which is this, I2 prime prime, that is 3 amps. Now multiply by its opposite resistive value, which is this, you have 2 divided by the same 2 plus 4. So we have 2 plus 4. This is giving us 6 over 6, giving us what? 1 amps. Now we can find the last one, which is I3 prime prime. So we have I2 prime prime minus I1 prime prime. This result is equal to 3 minus 1, which is equal to 2 amps. Okay, now that we've been able to find all the branch currents, we can superimpose the result or add the final result, add the result of this current with this one to generate our final answer for the original circuit. So now, let us find the real value for I1. So we take I1, write our I1 here, will be equal to, now let's compare, now watch very carefully, let's compare the direction of I1, look at the direction of the current, with our first diagram. Its direction is the same, so if it is the same, you pick the same thing, okay? So I write my word, I1 prime. Now let us compare this direction with the second diagram, I1 prime prime. When you look at it, you could see it is moving in the opposite direction. So you negate this one. It's not moving in the same direction with this. So what you need to do is that you negate it. So when we negate it, we have minus I1 prime prime. Do we get it now? What is the value of I1 prime? When you look at it, it was 6. So I have 6 minus, what is the value of I1 prime prime? When we look at the value of I1 prime prime, the result was what? 1. So when I subtract 1, we are getting what? 5 amps. So therefore the value of I1 is 5 what? Amps. Now let us work for what? I2. So for I2, I have my I2 here, giving me, now when we compare this direction with this, it is opposite. So we negate I2 prime. So I have my negative I2 prime. Okay? Then we go and compare the same direction with our second diagram. We could see it is moving in the same direction. So we take the same thing, the positive value. So plus I2 prime prime. And what is the value of I2 prime? The value of I2 prime here is 4 amps, but we have to negate it. So we have minus what? 4 plus, what is the value of what? I2 prime prime. I2 prime prime, we are having what? 3. So here, the value of this current is negative 1 amps. You explain the reason why the value is what? Negative. So we move on to the third one, which is I3. So let's find the value of I3. Now we find I3 by comparing. So I3 is giving us, now when we compare, you could see that I3 prime and I3 are moving in the same direction. Take the same thing. So we have I3 prime. Then we compare with the second one, it is also moving in the same direction. So plus I3 prime prime. Alright, so now when we input these values, we have I3 is giving us, what is the value of I3 prime? We got 2 amps. So I write my 2 plus, what is the value of I3 prime? We got what? Another 2 amps. So when I write this, the final answer is giving us 4 amps. Okay, so finalizing our answer, we have our I1 is giving us what? 5 amps. We have our I2 is giving us what? -1 amps, which is supposed to be 1 amp if we take the opposite direction. So you can rewrite that by saying, taking the opposite direction, I2 is equal to 1 amps. Just to explain this to the examiner, alright? So now our I3 is giving us what? 4 amps. And that is the final answer. So remember that anytime you take an opposite direction that gives you a negative current, you have to state it, okay? You have to let the person know that if you take the other direction, you're going to get a positive result. So that means that if I had taken the opposite direction here, I would have gotten what? 1 amp, which is still correct. So it doesn't mean that is wrong. Alright, so this will be all for this one. In the next video, I'll take another example, a little bit complex than this one, and we call it off for this topic. So my name is Daniel. Please subscribe to this channel if this video has been useful to you. You can share also with your friends, and I'll see you in the next one.